Hello? Hello?
Give me credit.
Huh?
At least give me credit.
Credit for what?
For coming.
Okay, I'm giving you credit. You did the warm-up.
No, that's not what I'm saying. Hello.
Stop.
Hello. Whatever.
Say that.
It's okay.
Hello this.
Huh?
Stop.
You
Hey,
stop.
hey, go ahead. It's your thing. I'm waiting on you.
What?
Hello?
Just
Hello.
What am I giving you credit for?
Hello. I can't. Can we just do this?
I have no clue what we're talking about.
Let's just do this.
Okay, explain to me later. All right, so where it is going to be concave up and concave down, right? So first thing I'm going to do is what?
second derivative.
First derivative. So it's going to be f prime of x is equal to 1 minus 2. What's the derivative of cosine? Negative sine, right? Of x. Or if you guys did it like this and said, hey, negative cosine, the derivative of negative cosine is a positive sine anyway. So it comes out fixed anyway. Concave up, concave down. So now take another derivative, right? So f double prime of x is going to be 2 cosine x. Now, where's that equal 0? So it's going to be 0 equals 2 cosine x. So the 2 is going to go away. So it's basically going to be x equals arc cosine of 0. So what does that actually mean? When I did the arc thing right there, that means I'm changing the angle with the x value. So I'm asking, unit circle wise, where is cosine going to be equal to 0 over the interval from 0 to 2 pi? Where is cosine equal to 0? So if you have a unit circle in front of you, you're staring at it right now, right? Pi over 2, right?
Pi over 2.
Okay, cosine, so we're going to have pi over 2.
There's two numbers.
Okay, so we have pi over 2, and we have 3 pi over 2. So that's the places in which that it's going to be equal to 0, right? Good. So we're going to figure out concave up and concave down in between there. So let's test it. So I have my inflection points right there. The points of inflection, which is going to be, pi over 2 and 3 pi over 2. So let's try the number line here. So I'm starting at 0, and I'm going to 2 pi, and I have, okay, so I have pi over 2. Let's say pi is here, and I have 3 pi over 2. All right, so let's see. Let's put in something in between. So between 0 and pi over 2 would be like pi over 4, right? That's an easy one. Pi over 4, that's positive rad 2 over 2, right? And where am I going to plug that into? First derivative or second derivative? Second. Concavity is going to be second derivative, right? Yes. Okay, concavity is second derivative. So let's go ahead and plug it into the second derivative. So it's going to be 2 times a positive rad 2 over 2. Is that positive? Okay. What was the rule for positive? It's concave up. There we go. So from here to here, I'm going to say that this is going to be up. Okay, from here to here, that's up. Okay, so now let's go from pi over 2 to 3 pi over 2. I'm going to plug in pi. What is cosine at pi? What is the x value at pi? Cosine is the x value. Yeah, so it's negative 1. So I get negative 1. So this is going to be negative, right? So that means this whole interval from here to here is going to be down, right? So if it's negative, it's concave down. And then let's take a look at 3 pi over 2 and 2 pi. Give me one in between there. Let's go 7 pi over 4. Okay, what is the cosine value at 7 pi over 4?
Square root of 2 over 2.
Positive, right?
Yep.
There you go. Positive, right, 2 over 2. And so all that's going to give me a positive number, right? So a positive means that this piece over here is going to be concave up. There we go. So now, what was the rule for it to be an inflection point? What was the special thing for it to be an inflection point?
It has to be changing
At that point, right?
at that point. Yeah.
Okay, good. I have that now. So at pi over 2, it changes. So that means, okay, so yeah, pi over 2, it goes from up to down. And that means right there, it's an inflection point. And at 3 pi over 2, it goes from down to up. That's also an inflection point. So let's see my eraser. Come on, bigger eraser, bigger eraser. There we go, better. Okay. All right, so my inflection point is going to be x equals pi over 2 and 3 pi over 2. Very good. Those are inflection points. Use second derivative test to identify any local extreme values. Okay. I'm going to come back to this here in a second, all right? So I'm going to use first derivative. So I'm going to insert a slide. So it was, what was my function? F of x equals, what was it? X minus 2 cosine?
Mm-hmm.
Right? Is that what it was? Yeah, there we go. Okay, so first derivative again would be 1 plus 2 sine x. There we go. So now, to identify local mins and maxes, I need to use the first derivative. First derivative and plug it into the second derivative. That is the second derivative test. So we're finding the points of 0. Those are going to be my mins and maxes, and we're going to test it using my second derivative. So that means take my first derivative, set it equal to 0. Let's do that. So 0 equals 1 plus 2 sine of x. Move the 1 over. So it's going to be a negative 1 equals 2 sine x divided by 2. Negative 1/2 equals sine of x. And then we're going to arc this one. So x would equal arc sine of negative 1/2. So again, what is that saying? Look at your unit circle, and where is sine equal to negative 1/2?
Nowhere.
Yes, there is places.
Nowhere.
Now think about it. Think about it. Sine is the y value, right? Where are the y's negative? On the bottom, right?
Yeah.
They're going to be on the bottom. They're going to be at. Look, keep thinking about it. Okay, so it's quadrant 3 and quadrant 4, right? So quadrant 3 and quadrant 4. Where is the sign going to be negative? So I know it should be.
Negative pi over 6.
And then 7 pi.
Okay, not negative, because what was my interval? My interval would be from 0 to what? 2 pi, right? So I'm not going to have any negative values. So I only want to have what's on the unit circle. So think about it. So
3 pi over 6. No, it's 7 pi over 6. I think it's 7. Like the pi over 6 plus pi.
okay, give me 1 second. I will. You guys scaring me right now. Let's just say it's a Monday, and just go with that. Can I borrow this? I'm just gonna say it's a Monday right now. Okay, it's a Monday.
I know it's wrong.
It would be 11 pi over 6.
We just said that. And you said no.
No,
Yeah.
I'm not saying no. I'm saying that there is a. I'm trying to get to this right here. This is what I wanted to do. Okay, so here's the unit circle. So remember, okay, 11 pi over 6 will work,
And 7 pi over 6.
and 7 pi over 6 right here, right?
Yeah.
So I was trying to get you guys to imagine where they're going to be. If sine's negative, That's the y values, right? The y values are all below the axis, below the x. So that means that everything over here, quadrant 3 and quadrant 4. Okay, so from here, negative 7 pi over 6 is going to give me this. And then right over here at 11 pi over 6 is also going to give me the same thing. So those are my two places I'm going to have. Okay, so let's go ahead and go back to my thing. 7 pi over 6. There we go. So we have x equals 7 pi over 6 and 11 pi over 6. Okay, now with those, I said we need to plug this into the second derivative. This is going to be the second derivative test. This is going to tell me if it's going to be a min or a max. Okay, because of concavity and all that, it's going to tell me if it's a min or a max. So let's plug in 7 pi over 6 into the second derivative. The second derivative was, it's right here, 2 cosine x. So we have f double prime of 7 pi over 6 is going to be 2 cosine of 7 pi over 6. And now, from those values at 7 pi over 6, that's going to be a negative rad 3 over 2, right? Yeah. Yes? Mm-hmm. Okay, so this is going to be 2 times a negative rad 3 over 2.
So just a negative rad 3?
So yes, it's going to be a negative rad 3. So the whole thing is negative, right? The whole thing is negative. So if it's negative, what does that tell me? It's going to be concave down. So if it's concave down, that means this is going to be a, do the hand,
Max.
Oh, yeah.
do the hand, it's max, right? If it's concave down, I'm going to give it a max right there. Yes? See, you guys are going to use the hand, I'm telling you. It's going to be interesting. You guys throwing up math gang signs. All right, so 7 pi over 6 is my local max. Okay, let's do the other one. So f double prime of 11 pi over 6 is equal to 2 cosine of positive rad 3 over 2. Oh, wait, crap. 7 pi over 6, I know, I skipped a step. I was all excited about it. Don't you get excited about math sometimes? What?
When the class is over.
Thanks. Man, the shade in here. All right, so 2 times positive rad 3 over 2. And so that's going to be a positive, so that means that 11 pi over 6 is going to be my because this thing is some nasty type of sine, cosine wave, let's go ahead and check it. Let's see. There we go. I'm bringing up that calculator, especially for those people that don't have any like this in their country. So it's going to be x minus 2 cosine, right? Cosine x, right? Yes?
The original function?
Yes, the original function. Okay, thank you. I'm hoping everyone's participating today. All right. There we go. There's my function. Let's change our window. Menu, window. What should my window be from?
0 to b.
0 to what?
To b. 2 pi.
2 pi, thank you.
2 pi.
Okay. Let's go with that one. There we go. All right, so technically for this, we said right here, so there was a change in concavity at this point right here, right? Yes? Change in concavity at this point, change in concavity at this point. What was my x values? Let's go menu, trace, graph. What was the x value that we had? So was it
Pi over 2.
7 pi over 6, right? Not, oh yeah, yeah. So for the max, I'm going to go right here. So it's going to be 7 pi over 6, right? There you go. There's a max, isn't it? What was the other one? 11 pi over 6. There's my min, right? Okay, there's local min there. Okay, let's check those concavities. That should be in between where it's changing direction right here. This would be a concave up here, while this is the concave down here. So let's do, what was it? Pi over 2, right?
Yeah.
So pi over 2. There we go. 3 pi over 2. So 3 pi over 2. 2. There we go. See, look, it's changing concavity. At this point right here, it's going from concave down to now being concave up.
Not looks like this.
Huh?
Doesn't look like it's changing there,
What do you mean?
but like it's still going down all the time.
It is going down, but if you're looking at it, so if you broke this up, this piece from here to here, that right there, is all going to be considered concave down. Right here, at that point of inflection, that's going to change right there, so this piece is going to be concave up. So if I break this, I could actually say this piece to here to the end of the graph is all going to be concave up.
But it's not going up.
It's not going up. It's not talking about that. It's just concavity. So think about it like that. So concavity, so it's going to be up while this side is down. And right here where my fingers go together, that's where it's going to change. So I could break apart at that. That's my inflection point. This piece right here is down. This piece right here is up.
Okay.
Make sense or no?
Maybe.
Yes? Still throwing up gang signs? All right, okay. Don't forget, like, subscribe, do your homework.